So here we need to find dy dx of this function that we've been given there. So the method of differentiation that we're going to use here is logarithmic differentiation. So now, when we introduce logs on both sides, so we're going to have ln open brackets sine pi x plus 2 here. Then we close, we have the power y equal to ln open brackets cos pi y plus 3 to the power x there. So now here we can go ahead and drop the powers there. So when you drop the powers, you're simply going to have y ln open brackets sine pi x plus 2 here. We close. Okay, this being equal to x ln cos x or cos pi y plus 3 like this here. So now differentiating throughout with respect to x here, so we just say we differentiate with respect to x there. Now differentiating with respect to x, we put the notation that now we've started differentiating there, so we say this function here, we differentiate with respect to x over y ln sine pi x plus 2. We close this side, being equal to dy, not dy dx rather, so dx there, sorry. Okay, so here we're differentiating this term as well with respect to x. So we have our x ln cos pi y plus 3 like this here. So now here, you notice that y here is a function and ln sine pi x plus 3 is another function there. So we have two functions that are being multiplied by each other. So meaning that there we're going to apply the product to them. So now we keep the first function y here. Then we differentiate the next function that we have there. So when we differentiate that function, we're simply going to have ln sine pi x plus 3. We're going to find 1 over sine pi x plus 2 there. Then here we notice one thing there, so let me just check if it's plus 2 or plus 3 there. Okay, so it's a plus 2. Okay, we're okay. So now here, then the next thing that we do here is we differentiate the function that we have on top there. So when we differentiate this function here, we're simply going to get the cos of this. So we're going to have cos open brackets pi x plus 2 like this here. So then again, we differentiate pi x plus 2 here. So when you differentiate pi x plus 2, we're simply going to get pi there. So meaning that here, we're going to get our pi, we can put it there. So plus, we keep the first function, ln sine x, ln sine pi x plus 2, like this. Then now here, when we differentiate y with respect to x, we're simply going to get 1, but then since y and x are two different variables, we're going to have our dy dx this side here. So dy dx like this here, equal to, we do the same thing this side, we keep our x first, then when we differentiate this function here, first things first, we're going to get 1 over cos pi x or cos pi y plus 3. Then when you differentiate cos, you're going to get negative sine pi y plus 3. So then when you differentiate pi y plus 3 inside there, you're simply going to get pi there. So multiplied by pi, you can just write it this side, pi. Then since y and x are two different variables, in front we just include dy dx this side, like this here. Then plus, we keep the second function, which is ln cos pi y plus 3 here. Then when we differentiate x, we're simply just going to get 1 there, so meaning that we can just leave it the way it is here. So now here, we know that when you divide a cosine function with a sine function, you get a cotangent function there. So meaning that this side, we have pi y. So pi y cot, open brackets, pi x plus 2 plus, then this side we have ln sine pi x plus 2 dy dx here being equal to, then this side here, when you divide these two functions here, you're going to get a tangent function, so meaning that here we have negative pi x tan pi y plus 3 dy dx like this here, then plus here okay, so then plus ln cos open brackets pi y plus 3 like this here. So now here, what we're simply just going to do here is we get all the functions that have dy dx, we put them one side, then everything that doesn't have dy dx, we take it the other side, then we make dy dx the subject there. So then here, we take this function that has dy dx the other side, it's going to be positive there, so we're just going to have open brackets pi x tan pi y plus 3, then plus ln sin x or pi x plus 2 here. Then we factor out what's common, which is dy dx being equal to, then when we bring this term here the other side, it's going to be negative, so here we're going to have ln cos pi x or pi y plus 3 minus pi y cot open brackets pi x plus 2 then. So now here we divide both sides by these two terms here, so we're simply just going to have our dy dx then. So therefore our dy dx will be equal to ln cos pi y plus 3 minus pi y cot pi x plus 2 divided by this term that we have here, which is pi x tan open brackets pi y plus 3 plus ln sine open brackets pi x plus 2 there. Okay, so if there are no errors, then this is the required solution.